mean, I'll take like.
Yeah, I don't think so, yeah.
It's not gonna
That was rough.
Eight for eight, bro. That kid went eight for eight in first quarter.
In the first quarter.
Yeah, we came in 18, bro.
He still should have won.
Okay, folks.
That was the luckiest game we've ever played. He scored like 30.
So just a reminder where we are. We started Unit 5 last time. We started Unit 5 last time with just one kind of a brief introduction to solving triangles, and it was all right triangles. So hopefully it wasn't too bad for you. Hopefully you're able to finish your assignment. If you weren't able to finish it, you'll have some time today to work on it, or maybe sometime later this week. There's no official assignment that you do today. I do want you to make sure that you handle all the material that we did last time. You'll see that we're on day 2 today of our unit. We're gonna be doing law of sines both today and the next time. Pretty exciting. Then after that, law of cosines. And after that, on day 5 of our unit, we're gonna be having a quiz on the first 4 days. So just so you know, I don't have a date for you then, but whenever that works out to be on day 5 there. So that area of triangles, which I know it's gonna be pretty difficult for you guys. Let's see. Oh, should I do a warm-up? I wish you Happy New Year. Happy New Year. I think I said Happy New Year. Hope you had a good break. Even though there wasn't any official homework, I know it's tough to get through and there's no math homework in particular, but I'll give you plenty this week. Don't you worry about it. Warm-ups, here we go. Dun-dun-dun. Let me see if that's right. Because you actually see these things.
One requires a calculator.
Unless you don't need one. Unless you already know all the different tangents. Yeah, that's a 20 degrees. We'll be covering some lucky young students, so please make sure you're okay with these problems. Oh, there's 1,000. That's it, correct, right?
It's 2.57.
Oh, that's just. Yes. What?
That's what we might.
Doing okay.
Oh, yeah, we're doing 1, 2, 3.
It's all up there. Oh, warm up.
No, it is.
SAS. Oh, I remember this. It's like. There was, the one we're talking about.
What's that?
Over.
Oh.
Don't have to cross them all.
Possible, right? I play poker, so I actually, well, play some bank.
Oh, nice. Christmas poker.
I. You?
I'm ready. Ready or not? Let's see here. We got, look at that. Andrew, could you help us with number 1, please? Right off.
So, the way I set it up, I use the German sign. So sign 20 is equal to 8 over, no, x over 8,
Okay.
multiply by 8 both sides. So you find x and you get the sign of 8.
Okay.
And so I got x equal to 2.7362.
Are we good with that? Thank you for including units. Very nice. I'm not a big stickler for that, but if units were included, like if it said inches or something like that, I would expect you to answer in kind. Nice. So we have sign equal to opposite of hypotenuse. So do you have going directly to it? If the opposite is equal to hypotenuse times sine, we just want opposite side. But if you just wanted the adjacent side, and adjacent would be equal to hypotenuse times cosine at that angle. Yeah, I think we're going directly to this, but it's fine, it's like here. Andrew, thank you very much, starting us off, right? For the second one, Brandon. Help us with number 2, please.
Yes, I can. So first, also need time. right?
Okay.
Trivia metric function.
Nice.
And then, and so I know sine to pi. So the 11 sine to pi. And then 11 pi is. So, I don't have to calculate, and this calculator is in
Oh,
English.
okay.
So 9.969.
It sounds like you don't believe in the calculator.
I'm swearing this.
Well, does it seem right? 9.969? It seems good, right?
It's because like
Pretty
the
low.
last one. Ravens was
Oh, okay, that's awkward. Yeah, okay. Any questions? Brandon, I'm really glad that you brought up the this issue there. What if your calculator freaks out during the test or quiz? What are you supposed to do? Now use your brain. Oh, you've already used your brain. If your calculator freaks out, if something happens with your technology, just your answer here. This answer is called, you know what it's called? Calculator ready? So that's fine. When you calculate it, it's not a calculator course, it's a trigonometry course at this point. So if you can get through the trig, I'm quite happy. Any questions on 1 and 2? Chazzy? It depends. It would be minimal, and it might just be 1 point for all of them if we did all calculator ready. Just because you should have a working calculator on a test, but that's not the main function of the test. Name all the ways to prove that 2 triangles are congruent. Please, everyone, would you please show me how many ways there are to show that 2 triangles are congruent? Okay, I'm seeing 3, 4, 5. Let's see. Okay, I want to hear from the one and only Rihanna. Can you tell us what you remember about proving 2 triangles congruent?
I remember on the other side of it.
Wait, is this one way to prove triangles are congruent? Is it?
Oh.
Yeah, this is one of the ways I'm looking for. So you're doing great. Oh, okay.
And then side.
Oh, okay. So
And then I think this is it, but I know you can't do it. And then side. I know that one's not.
okay, good,
not one.
good.
I don't know.
Oh, hypotenuse, right?
Ooh, hypotenuse leg, HL. Does that sound familiar? HL, so is that it for? If there's one more? Oriana said it's not, the SSA will say.
Oh,
AAS, is that one? AAS?
yeah, because it's no choice.
Because of no choice there, yeah, okay. Yeah. So ASA, SAS, SSS, are those postulates or theorems? Are they postulates or theorems? SSS and those first 3. It's never been proven. That's why they are postulates. Those first 3, at least not in your geometry class, they weren't proven. I think there might be proven in upper levels of math. AAS, however, is a theorem based on ASA, like you were saying, because no choice theorem AAS could be proven. HL, hypotenuse leg, proves that 2. What kind of triangles are congruent? Right triangles. Only right triangles have hypotenuse. So please don't try to use that on other kinds of triangles. Okay, rewrite AB equals CD as 2 different proportions. Okay, you can help us with this one. Well, actually, let me start us off. I hope this makes sense. Someone in another class did this. They have a proportion. They said, well, if AB equals CD, then A over B is equal to C over D. So what's the problem with this? Straight off the bat, yeah, Johan. Yeah, it doesn't match up when you cross multiply, and hopefully you're all familiar with cross multiplication with proportions. Here you can see that would be AD equals BC, which may be true, but if that A is up there, then what's forced is that B has to be diagonal to this. Does that make sense? Now, where do C and D have to go? And the other one. So one of them would be C here and D here, or A is to D as C is to B. I think both of these yield AB equals CD if you were to cross multiply. Are there other proportions we could have used? What would they look like? Just take both and take the reciprocal of both sides and you get the exact same thing. So there are actually 4 different ones. Anyway, just trying to bring back some good memories. How was it? Little warmth there from geometry. Let's continue with the last unit of trigonometry. Oh no. Oh no, let me undo what I just did. And what's going on here? Oh, I'm in the wrong packet. Okay, so last time we talked about solving triangles, which just means to find all of the side lengths and all the angle measures, and then the triangle is solved. And unit one was, or yeah, first section was really easy because it was all right triangles. When you have right triangles, you could find side lengths by using, well, Pythagorean theorem and a 9-letter word that is so right? So you can find those. You can find the angles, right? I think Pythagorean theorem will give you the side lengths, and then SOHCAHTOA will give you the angle measures. Is that right? I think that's how it works. So you were using that last time. But what if the angle is not a right triangle? How could you find the sides and the angles? I'm sure you could do part of it now, but there is a tool that you need in order to solve any kind of triangle. Now, do you know what a triangle is called if it's not a right triangle? Acute or obtuse, but that's two different names for two different triangles. Oblique, yes, an oblique triangle. How the heck did you know that?
You know, he did.
Oh, he didn't know it. He just said it from the ether. He didn't know it. But Andrew, how did you know that? Oh, I'm guessing that was Nathan. I think I talked about oblique pyramids at one point. I don't know. So I'm going to go ahead and build an important tool that you need to have here. This is not a right triangle. It is oblique. So we'll say that this is A, this is B, and this is C. I'm trying to find relationships. Of course, we know that side length A would be opposite from A, right? So it's always like this, unless otherwise noted. Now there is no right triangle, but I am going to make a right triangle by including dropping an altitude, right? We have an auxiliary segment that we could use here. Had you already visualized that? Okay, we'll call this length here H. And I want to know the length of H from the perspective of angle A. You see what the length of H is from the perspective of angle A? Just like we did in warm up, H is equal to B sine of A. And if you don't know where that came from, you could go one step back and look at it. You see that sine of A is equal to B over H. Yeah, I thought H was sine of A is equal to H over B. You can see that, and then sine for H is equal to B sine of A. So we did that with the left triangle. On the right triangle, you see what we're going to say? H is equal to A sine of B. And because this is true, the next step, logically speaking, should be that I'm gonna start with the first one. B sine A is equal to A sine B, even though it is the same thing. But let's write this as a proportion. You know how to write this up as a proportion? Let's start with sine A on the top. If sine A is on the top of the proportion, then what's forced? B would be, little b, of course, would be, what's that? Diagonal, like little b would be down here, wouldn't it? The other ones would go on the other side. I'm going to put the signs on the top. So sine B is up here, which means A is down here. And this is the first 2/3 of a law called law of sines. I'm not going to prove it here, but I'm going to hope that you take the leap of faith with me to understand that the third ratio would be, what would you think it would be? It's sine of A over A equals sine of B over B equals Sine of C over C. Law of sine. There is another version of it. We can take all of these fractions and reciprocate them, write the reciprocal of them all. A over sine of A equals B over sine of B. Are you all differentiating your lowercase and uppercases appropriately? And big B and little b are very different. Same thing with little a and big A. See, they almost look the same. Just do the best you can. Okay, so we are going to be using that today, and I'll put a square, or I'll separate that so you know this is the good stuff. That's important stuff here. How many of you have seen the law of sines before? Where did you see it?
Not too much.
Yeah.
Talked about it.
Okay, that's about it.
Yeah.
Same place. Or anyone else see it anywhere else? Chazzy, where did you see it? Anyone else see that? Studying for ACT? Yeah, I think that's pretty common. For ACT. Do you think you've already memorized it? It's a pretty nice relationship. It's a beautiful relationship between the parts of the triangle. So it says solve the AAS triangle. So I'm going to draw the triangle here. I'll put my A, B, and C, 102 degrees, 28.5 degrees. Did I draw this okay? It's super awkward, but we really don't care if it's we're just trying to find, we're ultimately trying to solve the triangle. All we care about is that things are opposite of what they should be. We can see that that 28.5 degree angle doesn't look like a 28.5, but remember in geometry, you cannot make any assumptions based on what you see here. So this angle is very definitely obtuse. And C is obtuse. Angle B is obtuse. Ultimately, it doesn't matter. We're just trying to find the measures of everything here. Now, do you see why this is called an AAS triangle? For the two angles and the side. Specifically, it's the side that is as opposed to AS, and this side is not in between, included. That means included side. So we're classified as AAS, and when you have AAS information, you can use the law of sines. So let us make a little chart. A, B, C. I'm not going to put equal signs for the sides yet unless I know them. A, B, C. B is 28.5. C is 102 degrees. Would it ever be appropriate to use Pythagorean theorem in a case like this? Yeah, please do not. I know that B is equal to exactly 27. So first thing I gotta do is find the length of side C. Now I really like to have my variables in the top of the fraction, and I recommend that you do too. But whatever you like. So I'm gonna say that C is to sine of 102 degrees as 27 is to sine of 28.5. Are we good with that? That's just the law of sines. You could put the signs on top or you could put the signs on the bottom. You can see that to solve for this, all I have to do is multiply both sides by sine of 102. So C is exactly equal to 27 times sine of 102 all over sine of 28.5 degrees. Any questions? Fancy I've given you is exact, and it's called calculator ready form. Could you please just make sure you can enter that in the calculator? Miles, were you able to get it? What'd you get?
I have 55 to 3,
Let's do 3 decimal places, unless otherwise.
3, 4.
Are we good with that? Did you all get the same thing? If you didn't get that, chances are that your calculator is in degree, so make sure you are in degree mode and make sure you're hitting the buttons correctly. I'll give you a minute to answer any questions amongst yourselves and then finish the triangle. You have enough information. Be calling someone just a little bit. Talk about A and A. Calling someone in just a few seconds. So check with the neighbor, make sure they're doing okay for the other 2 bits of information. Okay. We have it. Okay, Sabrina, can you help us out with A and A? Okay. $27 over sine 28.5, you said? One more time, I didn't hear that. Is that true? Are we good with this? Any questions? Nicely done, thank you. I noticed if you're gonna use, when you're using law of sines, please don't use all 3 ratios, it's too odd ratios between 2. We compared these 2 rather than these 2, which is a good choice because one of them is exact. When given a choice, please use the most exact information that you have. So this 27 over sine 28.5 rather than 55 equal 8 over sine 102. That'll get you pretty close, like really, really close. But when I look at the nearest 1,000, little errors in rounding, rounding just inaccurate. Unless you round like to nearest 10,000, something like that. Jazzy?
So when you're wrong, you don't always be able to
Oh, no, it's just A is the opposite from A, the option B. We don't care about what the bond is because it could be rotated. In fact, is a picture really necessary? Is the diagram necessary for this? You see that if we went back in time, let's see if I went back in time to the beginning of this problem, I think. Does it make sense that you would get C next and then just from what you know about triangles, just fill in the rest? In fact, my triangle is completely inaccurate. It's not helpful at all. At all. I'm just trying to visualize what's going on here, but it's not really necessary. Cool. So draw the triangle if you want. My suggestion is if you run into a problem and you're just not sure where to go, then draw it for sure and make sure you're drawing it accurately. Maybe a nice problem about frozen yogurt. I give you a chance to read it, answer it. I'll be calling someone to help with this one in just a moment. Checking with the neighbor before I call someone. Do you need some more time? About 20 seconds. Okay. I think we are. It's eerily quiet. Which is what's going on here. Hudson, how'd it go? Okay,
So I drew a little triangle, but that's not really necessary.
it's not necessary.
I mean, this type of problem, like it's so hard to define that.
So just like a triangle like this might help.
Yeah, I made mine, but the angles on it. But don't matter.
Okay, hopefully one's horizontal.
Yeah.
And then on the left side, did you kind of go up
It's 130.
or something like that? Okay. Okay, cool. So 130 degrees, you said. I think this one is 6.8. And then 28 degrees, excuse me. Okay. Did you label any points or anything?
Yeah. I labeled the side opposite to 130 Y,
Mhm.
and labeled the side opposite.
Oh, so this remaining angle is 22 degrees?
Oh, yeah.
Okay. No problem.
Yeah,
Nice. And but before I continue, I have to say, I really like that you're going away from A, B, and C, right? It doesn't matter what they're called. It's just about the relationships. So I'd like to see where you went from here.
Okay, and then I set up my equation using the law of sines. 6.8 over sine of 78 equals, inside of x over sine of 72.
Okay,
Plug that in, like that, x is 5.
approximately 5.426. Okay. And for the other one,
The other one, I plug the 6.8 over sine of 8. Side of y, sine of
okay,
then I got 11.2.
1.096. Are we good with this? Are the units? Miles, okay. Cool. Very nicely done. Thank you. Any questions? Yeah. Maybe something that please keep exact. I think that this is really important. Please do not round until the end. Don't round, like, don't plug in 52 factor and then function that around it. I mean, everything is calculated already. I'm gonna put all the numbers and be careful about rounding the prematurely. Any other questions? I did forget to connect some dots up here. One benefit to having the information like this is that you can make sure that the longest side is opposite from the, wait, longest side is opposite from the biggest angle, the shortest side. Right, so make sure that after you finish, everything lines up, because otherwise there is an error for sure. That's Chazzy. Yeah, of course. Also, my recommendation, when you have a variable, start with the variable, like, this is great, and there's nothing wrong with it, but I would personally say x is the sine of 22, as 6.8 is the sine of 1. But it's up to you how you do that. Okay, we have one more, just one more to do together. I think you can already do it. Should we draw the triangle?
No.
You can if you want. How do we see that this is ASA here? First, as an ASA, as has to be the included. Does that make sense? If this is ASA, makes a difference. To think about where little c is going to be on a triangle, it's going to be in between. And so when you see ASA in your triangle as well, it's not gonna be-
Get it? You check the neighbor, make sure that your answer is nice, right? You do nice to your neighbor?
Okay. Nola, can you help us out with this, please? Okay. Okay, I like it. I like it. Okay, nice. Okay, and you got an answer for that one? Nice. This is the important stuff. Thank you very much. Did you were you already working on entering that or? Okay, so far so good because angle B is bigger than angle C, so side B should be bigger than side C. So can you help us with A? Oh, you went right to it, huh? A equals 23. Wait, one more time. Sine 23 degrees over sine of 53, 63. Okay. 10.086. Does everything seem to line up okay? Shorts for shorts, big for big. Are the numbers right? Nicely done, Noah. Thank you. Any questions? Okay. Well, that's a big tool. That's half of or a third of the quiz, I guess, next time, isn't it? Hope you memorize that formula. I'm gonna give you some time now to work on either the last assignment, if you haven't finished that one, or just get started on this one. Some of you maybe will finish it in class. Oh, and I have your tests. Now you're getting your test back, so when are corrections due?
Monday.
Next week, it's always a class after the weekend that you get them back. Only if you got below 90%.
Yeah, I got that. Yeah, we start on one of the things. No, 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 I want to keep that. And I think it's one. Oh, it's not fun. I find